Hello everyone, and welcome to another part of the Galaga SDL tutorial videos. And in this video we're going to be automating a few of the things that we have so far in our game. So at the moment what we have is key presses, so SD and F, to spawn the butterflies, wasps, and bosses. And in this video what we're going to do is to create an XML file and list all the spawning patterns that we want for the first level in it, and then loading up this XML file and using it to spawn enemies instead of the key presses. So for this we will need to use an XML parser, and the one that I'm using is TinyXML. So if you search TinyXML2 in Google, and then in here the first link, you should have a GitHub link in that web page. So when you go in there, you can download the zip file, and once you have this downloaded, you should have a file that looks like this. And in this file, the only two files we're concerned about, or in this folder, the only two files we're concerned about is tinyxml2.cpp and tinyxml2.h. So we'll add these two to our project. In our project over here, we will right click on the project and open folder in Explorer, and then paste the two files in here. And then we will just add them to the project. So we will create a filter here. So add a new filter. We'll call this one TinyXML. And then right click on that, add existing item, and then go down to tinyxml.h. And then we'll do the same thing for the CPP. So in source files, new filter, TinyXML, and then add existing item, tinyxml2.cpp. And that's all we need to include our XML parser. Now we can go ahead and get started on the spawning itself. So for the level, we need 4 paths, and so far we only have 1. So we need to fix that first. So if we go to our enemy.cpp, let's see, where is it? Right here. We have the 1 path right now, and we need to add the other 3 that we need for the first level. So we will copy this and paste it, and then remove the int for the current path, remove the Bezier curve pointer for the path, and then we will just duplicate what we have here. We will change the current path to 1, and then the only difference between this one and that one is that we have a midpoint and we want it to be mirrored. So to have it mirrored, all we need to do is, since this is midpoint plus 50, we want this one to be midpoint minus 50. So this is going to be minus. So we'll change all the pluses to minuses on the x-axis. There we go. So all the midpoints, all the pluses are minuses to mirror it, but now we have the 75 and the 350. So for this, what we need to do is to just, instead of using the left side, which is starting at 0, we want to use the full screen side and then minus from that. So we will create an int. Full screen is going to be equal to the screen midpoint times 2, and then use this full screen variable to subtract the 75 from. So full screen minus 75, and then full screen minus 75, same thing here and here, and then the 350, same idea, full screen minus 350 and full screen minus 350. And that should be it for our second path. Now to test out this path, we can go to our level.cpp where we're spawning our enemy. So it was somewhere down here, there it is. So in handle enemy spawning, we can change the path from 0 to 1 and see what that looks like. So we will make, we will make the butterflies take the path 1 and the wasps take path 0. So we can see what the paths look like. So let's run this. There we go. And I think the butterflies were S. Yep. So the butterflies are going this way. So that looks good. And the wasps are going the other way. So this looks pretty good to me. So now that we have our 2 paths, we need 2 more paths. And we haven't created any of these paths yet. So let's go ahead and get started on that. So we will copy pretty much everything here. So, and then paste and change this to 2. So we just copied this path, and then let's remove all the add curves in here. And then the full screen as well. So, because all we need is just the current path is equal to 2, make a new Bezier path, push it, sample it, and then delete the path. So now we need to create our curves. And for this, our first curve will be, so path, add curve, and this curve will start off being, and the whole idea is we want, what we have right now is one path that looks something like this, and another path that looks something like this. The other paths that we want is one path that comes from here, does a 360 or almost a 360 down to here, and then they fly into formation. And then the same idea from the other side, it does the same thing and then fly into formation. And these are the 4 paths that we need. So for this path, we want to start off at, so vector 2, and we will need a couple of variables here. The first one will be called temp, so int temp is going to be equal to the screen midpoint plus 60, and temp2, so int temp2 is going to be equal to the screen midpoint times 2, or the full screen minus 40. These are the 2 points that we're going to need here. So temp1 is the midpoint plus 60, and temp2 is the full screen minus 40. And then let's go ahead and get started on, oh, actually, no. For this one, we want just temp can be equal to midpoint plus minus 100. I looked at the wrong path there. Okay, so temp is going to be equal to the screen midpoint minus 100. So let's go ahead and get started on the curves themselves. So we'll have vector 2. This one is going to be at negative 40 and 720. And then the control point is going to be a vector 2 of negative 50 and 720. Then the second point, control point for it, is at 0 and 720. Oh, it's at 10 and 720. And then the point itself will be a vector 2 at 0, and it's going to be at 0 and 720. So that should be it for our first curve. And then the samples will be 1, because this one is pretty much just a straight line. We just want the, what we have here is we want the enemy to go from the edge of the screen, so off screen, down to the 0 point on the X, so that we can start this curve right here. Okay, now that we have this, we can add our next curve. So path, add curve. And the starting point for this curve is going to be the endpoint for the previous one. So it's going to be this one right here. So 0 and 720. Then our control point for this one will be at 200 and 720. Then our next point is going to be a vector 2 at temp and 500. Then the point itself will be at vector 2 of temp and 400. Now the sampling for this one will be 15. And these will be the first 2 points. So let's test it out and see what it looks like. We have our bosses spawning here, so let's make the bosses take that new path. So that will be path 2. And let's see what it looks like. So our bosses are on the F key. There we go. And as you can see, it curves this way and stops here. So all we need to do now is make it rotate by almost 360, so something like 300 degrees, and then go there. So we just need to add 2 more curves to this path. So path, add curve, vector 2, and the start point, as usual, is the same as the end point of the previous path, so it's going to be this one right here. And then the control point for this one will be equal to temp and 200. Then next up is the next point, so this will be a vector 2 of 40 and 200, and the point itself will be at 40 and 400. Then the sampling for this will be 15, and let's try it out and see what it looks like. So that should be half a circle, and then we'll do the rest of the circle in the next curve. There we go, let's spawn the boss. And there we go. So it does half the circle. Now we just need it to continue to finish most of the circle and then go up there. So we're going to do another path, add curve, and the starting point is going to be the same as the end point from the last one. And then the control point for this one, oh, this one needs the V. So vector 2 of 40.0f and 500. Then the final control point will be at temp minus 120 and 600. And the point itself will be at temp minus 40.0f and 440.0. Now the sampling will be 15. And let's run it and see what that looks like. So this should be our full path. There we go. So it comes in, it does a rotation, and then goes there. So that looks about right. Now for our final path, we will copy and paste this path right here, change this to 3, and then temp, now we don't need int anymore, so temp is going to be the screen midpoint plus 60 this time around, and we will need an int temp2, which is going to be equal to our full screen minus 40.0f. So we need these 2 new variables. And then for the curves, what we want here is to have our, this one will be temp2 plus 40 instead of negative 40. And then this one will be the same thing. So temp2 plus 50. And then this one will be equal to temp2 plus 10. And then this one will be equal to just temp2. So that will be it for our first curve. Our second one will be equal to just temp2. And then next up is going to be temp2 minus 200. This one will be just temp. So this one is fine right here. This one is fine here as well. And then this one is fine, temp 400, and then temp 200. This one will be temp2 minus 40, and this one will be temp2 minus 40 as well. Then next up is the last one, which will be temp2 minus 40, temp2 minus 40, and then temp plus 120, and then temp plus 40. And that will be it for our path 3. So let's change the boss to use path 3 instead and see what that looks like. There we go. And okay, so that seems to be working. But as you can see, the boss is actually on top of the scoreboard. So we need to change that. And this is going to be changed in our playscreen.cpp. So in playscreen.cpp, we go down to our rendering. So our sidebar needs to be rendered after everything. So we'll just take it from the top and put it all the way at the bottom. And that should make it on top of everything else. So if we run this one more time, and there you go. As you can see, it comes out from behind the sidebar. Okay, now that we have all the paths finished, we can now create our XML file and load it. So we will do a file, new file, and this one will be an XML file. So Visual Studio already creates the header for us. We can go ahead and get started on the file itself. So we will need the first tag, which will be called level, and then a closing tag for this. We might as well save it. So we will go to our debug and we'll create a folder called data. So in data in here, we will go inside and then call this one level1.xml. Okay, now inside level, we will have one tag called challenging stage. So stage, and this one will have a value of false for this level since it is not a challenging stage. And then we'll put a slash closing the tag so that we don't need a closing tag for it. And then next up, we will have another tag called spawn. And this one will take a path, and this path will be 1. And then a priority. The priority is going to be 0 for this one. Okay, and we do need a closing tag for that one. So the priority is pretty much so that we can have 2 paths running at the same time. So if we have a priority of 2 paths of priority 0, both are spawned at the exact same time, because in level 1 in the game, we have our butterflies and wasps coming down at the same time from the top. And this is what the priority is for. Okay, so in here now we can create our enemies that we want to spawn. So enemy type is going to be equal to butterfly, and its index is going to be equal to 0, and slash close tag. And the reason why we're adding the index in here is so that we can specify exactly which enemy we want to spawn. So over here we want to spawn butterflies 1 through 3, so, or 0 through 3, so 0, 1, 2, and 3. Now for the wasps, we will copy the entire spawn tag and then paste it. It will use path 0 instead of 1. The priority is 0 as well because we want it to spawn at the exact same time as the butterflies. And then for here, we will change all the butterflies to wasps. And then the index is 0 to 3 as well. So that looks pretty good. Now let's see how we can load this file. We can now go to our level.h. And then here we need to include the tinyxml2.h. So include tinyxml2.h, and then we will be using namespace tinyxml2. Now that we have this included, we will need a few new variables. So in here, we will have an XML document, and we'll call this one m spawning patterns. And then we will need an int mcurrent fly-in priority. And this will keep track of which priority we're currently spawning, so which path with the priority. So if the current priority is 0, we're spawning these enemies right here, and then incrementing it to spawn more or the later paths. And then int mcurrent fly-in index. And what we're going to be using this for is so that, let's say we're right here, this is our index 0, we're going to be spawning this and that, and then we're going to be spawning this and that. But don't confuse this index with that index. This index just means which tag it is. So this is the first tag, so this is the 0th one, and this is the third tag, so this is the third one. And this is what we're going to be using the current flying index for. And then we will need a boolean. We'll call this one m spawning finished, and then float m spawn delay, and a float m spawn timer. And that's so that we can space out the enemies when they're being spawned. And that's pretty much all we need in the level.h. Now we can move on to our level.cpp. And in here, instead of everything inside the handles enemy spawning, we can just erase all this because we're not using keys anymore for that. And then we'll go down to the update and only handle the enemy spawning if the spawning is not finished. So if not m spawning finished, handle enemy spawning. And that's pretty much all we need in here. Now we can go back up to our handle enemy spawning and start by parsing the XML file. So the first thing that we need to do, first we need to actually initialize these variables that we have. So if we go back to the constructor, we can go down here to our so all the way at the end of the constructor, we can say std string full path is going to be equal to SDL underscore get base path, and then full path dot append data slash level1.xml. And we'll hard code it here for now, but we'll change it later so that it takes in, because we are already passing in the stage, so we can just change that later on. So full path, and then m fly in patterns. It did not recognize it. What did I call it here? Oh, m spawning patterns. So this one will be called m spawning patterns, is going to be dot load file, and this one will take a full path dot c underscore c string, or c underscore string. And that's pretty much it for loading the XML file that we need. Now current priority is going to start off being 0. The current flying index is going to start off being 0. Our spawning finished is going to start off being false. And the spawn delay is going to be equal to 0.2f. And the spawn timer is going to be equal to 0.0. And this should be it for all the variables that we need to initialize. Now we can go ahead and get started on a logic for creating the enemies. What is going on here? Odd. Okay, so for spawning the enemies, so in handle enemy spawning, we can first increment the spawn timer. So m spawn timer plus equals timer delta time, or m timer delta time. And then if the spawn timer is more than or equal to the spawn delay, what we want to do is to now check the element that we have. So we're going to say XML element pointer is going to be called element is going to be equal to m spawning patterns dot first child element, which is called level, and then first child, and then next sibling element. This is because, so we're getting level, first child is challenging stage, so we want the first, the next sibling to that, which is the spawn. So now that we have the spawn in here, what we want to do is to go through all the spawns. So we will need a boolean called spawned, which is going to be equal to false, and a boolean called priority found, which is going to be equal to false. And what we're using priority found is if our priority, total priority, is more than any priority found in here, then the spawning is done. Okay, so let's go back to our level.cpp and say that while element is not equal to null, so if we haven't went through all the spawns, if our int priority is going to be equal to element int attribute, and this attribute is called priority. So we are getting this attribute from the XML file right here. Next up is XML element pointer. Child is going to be equal to element first child element. And then int path is going to be equal to element int attribute, and this one will be called path. And maybe we can put this one right here. So this one is the path right here. So now we have the path that we want to take and the priority of the path that we want. And then we need to now check whether our priority, our current priority, is equal to the priority that we just got from this element. So we can say if the current flying priority is equal to the priority that we just loaded, then we need to do some logic. So we can say that our priority found is true because we know that our current flying priority exists in here. And then for int I equals 0, I is less than the current flying index, and the child is not equal to null, and then I++. And what we'll do here is child equals child next sibling element. Okay, so what we're doing here now is that let's say our flying index is 2, but our first child is child 0. So what we want to do is loop through and count 0, 1, 2 so that our child is this one right here. If it's null, then we can't find it, so we break out, and this is what the child is, as long as the child is not equal to null. If it's not null, we'll just keep counting until we reach the child that we want within the tags that we have in the XML file. Okay, now that we have the child that we want, we can go here and say that if the child is not equal to null, we can now spawn this child. So we can say std string type is going to be equal to child attribute, and this is the attribute called type. So we're loading up in our XML our enemy. We have the child right here. We're loading up the type of the child. So now that we have this, we can say that index is going to be equal to child int attribute called, oh, not int64, int attribute called index. So now we have our type and index, we can spawn the enemy that we want. So if the type dot compare, and this is, if this is equal to butterfly, so that's equal to 0, enemies dot pushback a new butterfly, and this one will take the index, the path, and the challenging will be false for now. We haven't dealt with the challenging stage value yet, so we'll just keep it for now and we'll just set it to false. by default. And then else if the type.compare is wasp is equal to 0. So if we're trying to spawn a wasp, enemies dot pushback new wasp, and for this one we will give it the index, the path, false, and the diver can be false for now as well. We'll deal with the diving later. And then else if the type dot compare is boss equal to 0. Well, boss equal to 0. What we want to do is say enemies dot pushback a new boss with index, path, and false for challenging stage. Okay, now we also need to increment the butterfly count, the wasp count, the boss count. So right underneath the pushback, we can say butterfly count plus plus. We can say here wasp count plus plus. And over here, our boss count plus plus. Okay, and that should be it for our spawn logic. Now, if the child is not equal to null, we can safely say that we're going to be spawning something. So we can say right underneath here, still inside this if statement, but underneath the boss spawning, we can say spawned is going to be equal to true. Okay, now to move on, over here, so inside the element is not equal to null, we can now say here that we want to move on to the next element, because this is what our while loop is for, is to loop through all the elements. So right before we exit the while loop, we can say element is going to be equal to element next sibling element. So just keep iterating through all the elements. Okay, now that we have finished all this, we can check whether we found our priority or not. So if not, priority found. So if the priority doesn't exist in our XML file, then we finished spawning. So we can say mSpawning finished is going to be equal to true. And then else, so if we did find the priority, we can say that if we haven't spawned anything, so we were supposed to spawn, but we didn't spawn anything. And the reason we didn't spawn anything is probably because we finished all the indices that we have. So for priority 0, we spawned all the enemies. So we need to move on to the next priority. So in here, if not spawned, we can say boolean flying in equals false. So now we need, before we move on to the next priority, we need to make sure that all the enemies that we spawned for this priority already join the formation. So for int I equals 0, I is less than enemies dot size, and then I plus plus. Whoa, what happened here? Oh, extra one. I plus plus. There we go. If enemies at I current state is equal to enemy fly in. So if any of the enemies are flying in, so we can say that our flying in is going to be equal to true. And if the flying in is true, then we don't want to do anything. We don't want to move on to the next priority until it's false. So we need to wait. So over here we can say if not flying in, we need to set our current flying priority plus plus, so increment our flying priority, and our current flying index is going to be equal to 0 to reset it back to the first element. Okay, so that would be this section of our handle spawning. Now, if we did spawn something now, so over here, if not spawned, over here we need an else. So if we did spawn something, what we want to do is to increment the spawn index. So current spawn flying index plus plus. Okay, and finally, over here, so when we have, where we have all this here, right before we exit this function or this if statement, what we want to do is to reset the timer back to 0. So actually it's, let's see, we are going in here. So what we want to do right before we exit this one, so right here, we want to say our spawn timer is going to be equal to 0.05. Okay, and I think that should be it. So let's run it and see what it looks like. Let's see what kind of errors we caused. There we go, so stage 1. And we have 4 and 4 coming in, so that looks pretty good. And then it's stopped. Okay, so let's see what's going on here. So let's try to pause it here. Nothing here. So it doesn't seem like it's going in here at all. So what is going on there? Oh, right. The reason is that if we go to our XML, it already spawned everything that we gave it in here. So we just need to add now more and more, enemies for the entire stage. So we can add another spawn now. So spawn, and this one will take path 2 this time around, so path equals 2. And the priority for this one is going to be equal to 1. So we want this one to happen after these 2. For this one, in the original game, we had them coming in from here, and they were coming in the order of boss, butterfly, and so on. So 4 bosses and 4 butterflies. So here we'll say enemy type equals boss, and the index for this boss is going to be equal to, and in the game the boss is spawned as 1, 2, 3, 4. They don't go like the butterflies, so they didn't, because usually we have them spawning like here, 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 and there, but for the bosses they spawn 1, 2, 3, 4. And this is where the index comes in handy. So for the index, we know that our indices are labeled as, this is 0, 1, 2, 3. So we can spawn boss 2, boss 0, boss 1, and then boss 3. So in the index, we can spawn boss 2. And then we will say enemy type is equal to butterfly. And its index is going to be equal to, so we already did 0 to 3. This one will be 4. So /n. And then we will duplicate these 2. But now from 2, this one will be, the boss index will be 0. And this one will be 5. And then we'll duplicate it again. The boss index for this one will be 1. And this one will be 6. And then it duplicated one more time. And the boss index will be 3. And this one will be 7. So let's run it and see what that looks like. Oh, we'll probably remove the breakpoint right here. And this one too. There we go. So our 4 spawned. And then these 8 coming from the side, and the bosses should be 1, 2, 3, 4. So this seems to be working pretty well. Now we can move on to the next spawn. So the next spawn is from the other path, but it's 8 butterflies in a row. So we can go back here and say spawn. The path is going to be equal to 3 this time, so it's our last path. And the priority is going to be equal to 2 because we want it happening after this one. And then we can say, we can pretty much copy this one. So because we want 8 butterflies, but instead of this one will be 8, 9, 10, 11, 12, 13, 14, and 15. So these are all the indices that we want in here. So let's run it and see what that looks like. Okay, that looks fine. And then these 8, and then we should get 8 butterflies from this side. Here we go. And yeah, that looks pretty good. Now the final thing is to finish up the rest of the wasps. And the wasps come in from the top. So we'll say, we will pretty much, let's copy this one right here and paste it here. Our path for this one will be path 0, so that's fine. Our priority will be 3 because they come in after this one. And then for the indices, we already spawned 0, 1, 2, and 3. So we will do 4, 5, 6, and 7. But they were 8 wasps at once from this path. So we will duplicate it again. And then this one will be 8, 9, 10, and 11. So this is 4 through 11. And let's see what that looks like. There we go. And then we should get ones coming in from here. There we go. So 8 of them. And they are going into formation. Yep. Okay, so the last one now. So we can just copy this one and paste it again. But the path for this one will be 1. The priority will be 4. And then we will go from here. So 11. So this is 12, 13, 14, 15, 16, 17, 18, and 19. And that should be all the enemies that we need for stage 1. So if this works, that will be pretty much it for stage 1 spawning finished. There we go. So that's this side, 8 butterflies, and then we should get 8 wasps, and then 8 more wasps. And then once they're all spawned and they're all into formation, they should start the breathing animation. There we go. Okay, and that should be it for automating our spawning. I guess in the next video, we're going to automate the diving patterns next. So once we have the diving patterns finished, we can just do the collision detection and the player capture, and that's pretty much going to be it. And then I guess we can do the challenging stages and so on. But for this video, that should be it. I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.